Hi and welcome to Maths class. Today we're looking at finding rules for exponential and log graphs. So the key skills we're looking at today is we're going to use substitution first of all to create a set of simultaneous equations and solve that. We are going to do it on our CAS calculators. So then we're going to learn to solve these sets of simultaneous equations, but as I said, using technology rather than by hand, although there is one example where I'm going to do it by hand because it's pretty straightforward. So let's have a look at our first example here. We've got the equation y equals a times e to the x plus b, and we need to find the values of a and b. So what we need to do is write some equations. So the first thing I'm going to do is I'm going to look at the 2 points that I've got, and my first point is my y-intercept at 0, 5. Now I can use that to put this into the equation where y equals 5 and x equals 0, which gives me 5 equals a e to the power of 0 plus b. E to the power of 0 is 1, so that's 5 equals a plus b. Then I look at my second point, which is at 2, 12, and I'm going to substitute that in the same way. 12 equals a times e squared plus b. Now, you can do this by hand. It's not too complicated, but I'm going to show you how we're going to do this in our CAS. So there's my CAS calculator, and you can see that what I've entered there is I've got the two equations written in. 5 equals x plus y and 12 equals x times e squared plus y, and I'm solving for x and y. Of course, x here is a and y here is b. So I just hit enter, and I check first that my calculator is set for standard, and I hit enter, and there are my two solutions. So all I'm going to do now is I'm going to go back to my where is it? Shuffle that. Oh no, I don't want to move that. Okay, I'll hide that. There we go. Go back to my original working, and I'm going to jot down those solutions. A is 7 over e squared minus 1, and b is 5 e squared minus 12, again over e squared minus 1. Now I'm just going to go back to my CAS just for a moment because I really want to make sure that everybody knows how I went about doing this. So what I do is I go on my calculator, I go into my keyboard, and the thing that I'm looking for is this little symbol here, which gives me the little one-sided curly brackets, and that, oh, I'm not clicking on the right thing. Here we go. The one-sided curly brackets, and when I click on that, that gives me the empty set of equations that I need to solve. And then I just type them in and then hit enter to solve that. Okay, so now let's go to the next example. So my next example is a logarithmic function y equals a times log base e of x plus b, and I need to find the values of a and b. Now I've already jotted down that b equals 3 because what I can see there is that my vertical asymptote is at x equals negative 3. So that tells me, and the other thing that tells me is the equation, right? I can see that there is only a horizontal translation and a vertical dilation, which is the a. That the vertical dilation won't affect the asymptote. So the only thing I need to look at is the translation, which gives me b equals 3. So because x minus negative 3 is going to give me x plus 3, so b is 3. Now, if I try substituting in my x-intercept, what I get is y is 0 and x is negative 2. So I end up with this equation 0 equals a times log base e of negative 2 plus 3. Now if I use my normal method of the null factor law, that either gives me a is 0, well that will just give me the equation y equals 0. So that's not the answer I'm looking for. Or it gives me log base e of 1 equals 0, which is always true. E to the power of 0 gives me 1, therefore log base e of 1 gives me 0. So the reason that was so useless is because this negative 2, 0 is also located simply because of the horizontal translation. So I've used that translation twice now, and it's not going to give me any further information. I need to look at my next point, at 1, 3. And so I'm going to substitute in now x is 1 and y is 3. So let's have a look at that. So cross that off. That's no good to me. Now I've got y is 3 and x is 1, which gives me 3 equals a log base e of 1 plus 3, which is 3 equals a log base e of 4, giving me a equals 3 over log base e of 4. And that's the answer. So I've solved it. I've got b equals 3 and I've got my answer for a. So I've found both a and b. Now I've got one more worked example. So here's my last worked example. We've got the graph of y equals a times e to the power of bx goes through the two given points, and we need again to find the values of a and b. And once again, I'm going to do the same thing. I'm going to substitute in the 2 points in order to make 2 equations. So that gives me 5 equals ae to the power of 2b, and 12 equals ae to the power of 3b. Now this is a kind of equation we haven't seen before. We're used to solving simultaneous equations by addition and subtraction. Now you could put this into your CAS and CAS will find you a solution, but I'm just going to take you through how to do it by hand. So what we're going to do here, because the 2 parts of the variable, there's the a and there's the part which is the exponential raised to something times b, those are connected by multiplication rather than by addition or subtraction. So that means if I want to cancel something out, I need to divide. So in fact, my next step is this. I'm going to go equation 2 divided by equation 1. And that will give me 12 divided by 5 on the left-hand side. The a's will cancel on the right-hand side. And then because these are both to base e to the power of 3b divided by e to the power of 2b will give me e to the power of 3b minus 2b. When we divide, we subtract the powers. Simplify that, I get 12 fifths equals e to the power of b. b is log base e of 12 fifths. All right, so far so good. I substitute that back into equation 1. And that gives me 5 equals a times e to the power of 2 times log base e of 12 fifths. I'm going to rewrite that by taking this 2 here, and I just take that and I make it a power of the argument, which is one of my log laws. That leaves me with this expression, a times e to the power of log base e of something. Now, e to the power of log base e of something, that's an inverse operation, which means it cancels each other out. Going e to the power of log base e, it cancels each other out. So what I'm left with on the right-hand side is a times 12 fifths squared. I simplify that and I get a is 125 over 144, and I've solved it. So you've had a couple of examples there. Well, one example where I used my CAS, and a couple of examples when I worked by hand or I used other clues. So that is how we find the equation when we're given some key information about the equation, such as the form of the equation and the right number of points that we need. So that's it for that video.